Quiz 13 is starting us off here on question 1 with this equation. F of x equals e to the negative 8x. And what we're really learning about in this, like I just said, is the special case derivative for e to the x. So if f of x ever equals e to the x, the derivative of e to the x is just e to the x. The one thing to note here, though, is as soon as that is anything more than just a simple x, so then just a basic x up in that power there, it's a chain rule problem. So the majority of e to the x derivatives that you're going to have to take will end up being chain rule problems. And that's what we're looking at on this problem. We can see clearly that there is something more than just an x up inside there. It's not a lot more than an x, but it is something more than just an x. And so we know that what we're going to have to do is follow our chain rule. And so my chain rule is saying is d in times d out. The derivative of the inside piece times the derivative of the outside piece. And so what I consider to be the inside piece is whatever replaced that basic x in our power on our e. So in this problem, the inside piece is that negative 8x. The outside piece here is just going to be this e to whatever. So when we come to take our derivative right now, we follow our chain rules saying. So it says dn, the derivative of the n, the derivative of negative 8x would just be negative 8. The derivative of the outside on an e is the easiest derivative you'll ever take. It just follows that special case and stays the exact same. And so that would be our final answer.